Welcome to the National Energy Dispatch Center, CDC, of the Coordinador Eléctrico Nacional. The Coordinador is a technical and independent organization in charge of coordinating the operation of the facilities of the National Electrical System that runs between Arica and Chiloé under the principles of secure operation at minimum cost and guaranteeing open access to the transmission system. You are at the Energy Dispatch Center, a place that has cutting-edge technology for continuous and permanent supervision and monitoring of all electrical systems operations. In front, there's a 100 square meter video wall, which began operating in 2022. The CDC operates 24 hours a day, 365 days a year. Its team is made up of 8 roles. That includes a shift supervisor who leads the operation, dispatching engineers who have different roles, from supervising generation and transmission to overseeing reliability aspects of the grid, and a role to manage intraday programs that allows dispatching all power plants, which is adjusted hourly according to changes that occur in real-time operation. From left to right, the first information the video wall presents are a geo-referenced system that displays forest fires that approach electrical installations and which, depending on the events that may occur, allow us to make operational decisions in coordination with those responsible for the affected facilities. The second panel shows a map of the country with a general display of how the country's electricity demand is being supplied with a breakdown by type of technology: solar, wind, biomass, hydraulic, thermal, and other small distributed generation resources. Then you can see 4 charts showing daily energy profiles by generation type. The first one shows the solar generation profile, a resource that is massively deployed in the northern part of the electric grid and is very stable due to its geographical location. The yellow lines show the total contribution minute by minute, and below, the share of generation in the northern zone and the rest of the country. The second chart displays the evolution of the wind generation. The biggest challenge we have seen with the wind resource is the high variability it presents during the day, which is addressed by performing comprehensive generation forecasts and making use of flexible resources from the rest of the generating park. The curves below show the aggregated generation for the entire system, the sum of the wind and solar generation, and then the contribution from thermal and hydraulic power plants. Finally, you see the curve that shows the net demand of the system. This net demand corresponds to what is required to be generated to supply the total demand, discounting solar and wind energy. When the sun sets, the generation ramp can reach up to 5,000 megawatts in about 3 hours, almost 50% of the total system's peak demand. The next displays show the stability of the electrical system. Specifically, this chart presents the evolution of the system frequency that measures second by second the balance between electricity supply and demand. If more generation is provided than the system demand, the curve would remain above the nominal frequency of 50 Hz. And if the generation is less than what is required, the system frequency would move below that nominal value. This balance must be maintained for the system to operate correctly. This is supported by this chart, which shows the availability of reserved resources for secondary frequency control. Today, this module sends automatic set points to the generating plants every 4 seconds, which allows the frequency to be within the ranges established in our grid code. The information displayed on the video wall can be adapted to various needs. For example, this chart shows the power oscillations resulting from changes in the configuration in specific areas of the grid, and those are monitored in order to make timely decisions in the event of possible contingencies. In the center of the video wall, you can see a diagram of the backbone of the National Electrical System, that is, the most critical high-voltage transmission lines. The diagram shows the voltage levels and power transfers in real time. The transmission network extends for 3,100 kilometers, integrating nearly 38,000 kilometers of lines from Arica to Chiloé with different capacities and voltages. The blue lines correspond to the highest voltage level of 500 kilovolts. The green lines correspond to lines of 220 kilovolts that allow reaching specific areas of the country. There are other colors that represent lower levels of voltage in specific areas. Dispatchers can zoom in on their consoles to see what they require in greater detail. Then you'll notice a display with bar charts showing the main power plants by type of technology: thermal, solar, wind, and hydraulic. This enables us to see the instantaneous generation for each of these plants. On the right are tables showing the voltage levels throughout the system, which allows us to have a real-time diagnosis to make timely decisions. This is important given the extent of the grid and the need to maintain bus voltage profiles within normal ranges at every time. Finally, at the bottom, we maintain a news channel that provides information in real time and that can be useful for the operation, in addition to the evolution of the marginal costs of the system in different locations, which is the value at which electricity transactions are traded in the short-term energy market. This National Dispatch Center allows us to be prepared for the new challenges that the energy transition imposes with an experienced human team that is well-trained and equipped with cutting-edge technology. Thank you for visiting the National Energy Dispatch Center of the Coordinador Eléctrico Nacional. We hope to have conveyed the importance of this facility that is critical for the reliable and economic operation of the electric grid and the development of the country. At the Coordinador Eléctrico Nacional, we serve Chile with energy.